try this. Okay, I can hear the mic is working. Class hasn't started yet. It's about 4 minutes late. Any more questions? Try to give brief answers on questions that may be bugging you. You could even ask me a question that you asked Professor Kolomensky and see if I give the same answer. Yes?
There was a controversy around smart meters and that they send out harmful rays that will cramp in cell phones and everything.
Okay, the question is about the controversy about smart meters and that they send out a radiation, which is true. They send out microwave radiation, and that's how they communicate with the central headquarters. And some people object to the fact that the smart meters are required on their homes because they don't want more sources of radiation. This comes about because too many people in California have not taken physics for future presidents. And so they are vulnerable to a particular kind of person that has existed for thousands of years. My favorite example is Savonarola, who was the crazy priest at the time of the Borgias, who wanted all art burned because the Bible prohibited depicting humans, he felt. And all sorts of great works of art were burned because of him. He got a lot of people excited. And you can get people excited today by coming up with anything that's new. Tell them it's dangerous. And you can become a hero. And this is what's been happening with these smart meters, which is a real tragedy. Because the smart meters, they were actually invented and put forth by Art Rosenfeld, who's a retired professor of this department, who I will meet with later this afternoon, when he was California Energy Commissioner. And the idea is that we would like to be able to charge more money when electricity is short on a hot day. And this means you wouldn't turn on your dishwasher at the hottest part of the day because that's when electricity would be most expensive. So a smart meter would let you know what's happening, would even enable you to turn off some appliances if you choose to when the rates go up. But to do this, it has to send out a signal. The signal is very much like a cell phone signal. Now, there are similar scare stories about cell phones because they're new and you can scare people. And some people say, don't use cell phones at well, for example, gas stations, because they may make the gas station explode. It's utter nonsense. And it's never happened. But when a technology is new and a lot of people don't understand it, it's easy to scare them. So there are two messages to get out of this. One is, you are going to be among the most educated in physics of people you know. And so pass this on to other people. You can speak with authority just from having taken this class. The other message is, if you really want to become a multimillionaire quickly, one of the quickest way to do it is to become a Savonarola, to start scaring people, and you'll find the money starts flowing in. It's totally immoral, but it's a good way to make money quick if that's what you really want to do. How are we doing?
Well, so it's not explained normally, but when it goes into PowerPoint presentation, then it's showing up well. So if all you need to do is show the PowerPoint, then that's going to function. Did this work last?
Because these have been good questions. Any other quick questions before we begin the required material? Actually, a few announcements I have to make. That. I thought I'd show you that. I was in China last October, and watch the panda, and watch what he does with his left hand. So let me get this thing running. So in one place in the world where you can do that, that's in Chengdu, China, where they have a special panda reserve. And I think maybe you saw last week or the week before Hillary Clinton doing a similar thing. I got to hug a panda. Okay. Okay, today I'm going to talk about global warming, going to talk about air pollution and fracking. Here's a more detailed outline. I'll cross things off as I get to them. First, an announcement about grades. Don't worry about this. Yury asked me to make this announcement. Everybody's making the announcement today. Some of you probably came in for an 8 o'clock class, so you already heard the announcement. It'll be in the Daily Cal tomorrow. Okay, oops. So the announcement is the university has decided that we have too much grade inflation, and there has to be a change in the grading. So all the classes have been reviewed to see what the grades are. Some classes give all A's, no more. A's will be 10% of the grades at most. The other classes, so Yury's grading is actually fairly good, so it's only a minor change. Most A's will become B's, unless you're getting an A+. Most B's will become C's. The whole idea here is a B is supposed to be a good grade. Shouldn't have to get an A for it to be a good grade. So this is being made across the campus, and every class is announcing it today. So as I say, don't feel bad. If you're getting an A now, you'll be getting a B. Doesn't matter, because B will be considered a good grade. Presumably the whole world will know this when they look at Cal grades. So that's the first announcement. Second announcement is about an old tradition called April Fool's Day. Today is April Fool's Day. And on April Fool's Day, people tell you something that isn't true. And they try to make you believe it. And then they say, April Fools. So if you haven't caught on, April Fools. Okay, after that mean thing I just did to you, let's talk about, so I did the announcement. I did the April Fool's Day. Let's talk about the greenhouse. First, let me take a quick quiz. Don't talk to any of your neighbors. Don't share any information. I want to see, for my own information, the following. I'm going to write down some initials. I'd like to see how many of you recognize them. And again, don't share any information with neighbors. This is not a quiz. You're not being graded on it. It's mostly for my own information. Okay, raise your hand if you recognize those initials. Look around and see that about probably a quarter of the class recognizes those initials. I'm going to write two other initials. I want to see if you recognize them. Here's another one. How many recognize this? Raise your hand. You don't? Do you or don't? I just need to know. Yeah. Then why don't you raise your hand? Please, if you recognize this, please raise your hand. So I can call on any one of you and you tell me what it is, right? Do you recognize this? Raise your hand. Raise your hand if you recognize this. Of those who are raising their hand, how many of you could actually tell me what the four letters stand for? Okay, what do they stand for? International Panel of Climate Change. Close enough. It's actually the Intergovernmental Panel of Climate Change, but that's close enough. This is climate change. The reason I write these four letters down is they are important for you to know, believe it or not. If you're interested in world affairs, if you're interested in what is happening in Chechnya, what is happening in North Korea, what is happening anywhere around the world, South America, what's happening in the US. You need to know the United Nations, obviously. Well, these days there is an organization that is equally important on climate change. It's called the IPCC. The CC stands for climate change. It's been around since at least 1990. It's organized by the United Nations in collaboration with the World Meteorological Organization. No, you don't have to know that. But it is the international organization that makes a report every 4 or 5 years on the status of climate change. And their most recent report came out yesterday and was in all the newspapers. And now you'll start noticing it because you've seen these initials. And you are required to know these initials for this class. You're required to know that the IPCC is the big international organization that determines what we call the consensus on climate change. It stands for Intergovernmental Panel on Climate Change. You don't have to know that. But you have to know that the IPCC is the organization. It has something like, I don't know, 1,000 authors. They all get together and they decide and they vote on what they're going to say. And they review the science. And it's an extremely important result. And you'll see it referred to every place. When I write op-eds, by the way, how many people here, raise your hand if you do not know what an op-ed is? If you don't know, okay. So what's an op-ed? Yeah, it's something you could write to the newspaper about your opinion. Op-ed stands for opposite the editorials. So on the newspaper, New York Times, for example, they see editorial page, and opposite to that are editorials written by other contributors. Some of them regular, contribute every week. Some of them, like me, just contribute now and then. And when I write op-eds, I refer to the IPCC, but the editor always insists we say it is the Intergovernmental Panel on Climate Change. Not that that helps anybody who doesn't know what it is already. It's this big organization, and they review the data, and they make decisions. And when you hear about the consensus, or there'll be headlines this week about the new report that came out yesterday, and about the concerns that it raises about the future of climate, and the concerns it raises over the fact that the world is not acting very rapidly on doing anything about it. And that's really the topic of today's talk. It's also true that there are many scientists and other people around the world who disagree with the IPCC. So although some people will say, look, it's the consensus, that doesn't mean it's right. And so you need to be aware of this. I'm going to go through some of the areas of controversy today and tell you what's being said, what's being misinterpreted, and so on. But in the climate change business, the IPCC is the central organization. Now, the biggest issue came about in the 1970s. A scientist named Roger Revelle, I put his name up there. Did I? Here it is. Roger Revelle, I knew him. Used to talk to him down in San Diego, also up here up in Northern California. We used to meet. And he was worried about the future of something he referred to as global warming. So in the 1970s, he got a group that I was associated with. I didn't actually work on this, but I was associated with a group that did a report on global warming based on what Roger Revelle was saying. He also inspired Keeling to start making measurements of carbon dioxide. He was concerned that the carbon dioxide in the atmosphere was increasing because people burn fossil fuels. Now, fossil fuels consists of coal, which is mostly carbon, called C, chemical element carbon, but also petroleum, which is mostly hydrocarbons. And hydrocarbons are long molecules consisting of CH2, carbon and hydrogen. There's also natural gas. And that's mostly, and I'll just put the formula CH4. It's called methane. These are important for you to know. It's not that hard. When you burn coal, or you burn C, you get CO2, which is carbon dioxide. And carbon dioxide is the most notorious greenhouse gas. It's what's causing virtually all, not all, but most of the global warming. So we are burning coal, and that puts carbon dioxide into the atmosphere. And that's causing the greenhouse effect to give us global warming. That's a logic that you need to understand. Many people you'll find confuse this with all the other environmental issues that you hear about today. There are so many of them. But greenhouse warming is going to be one of the dominant ones. I'd say one of the two most dominant ones over the span of your lifetime. And if you understand this, you can explain it to your parents, you can explain it to your friends. Now, suppose you burn petroleum. Burn petroleum. By the way, petroleum is what in the United States we call gas, gasoline. Trouble with using the term gasoline is that you abbreviate it as gas, and that can get confused with natural gas. So in Britain, no one says gas or gasoline. They say petroleum or petrol. Anyway, be aware of that potential confusion. You burn that, you're burning basically CH2. And burning means combining with oxygen. So what you get is CO2, and you also get H2O. But much of the energy comes in producing H2O, which is water. And that does no harm to the environment. So it's better to burn petroleum than to coal if what you're worried about is CO2. What about natural gas? Well, there what you're burning is CH4. And so what you wind up getting is CO2, H2O, and H2O. The result is, for the same energy, you get much less carbon dioxide. A lot of the energy comes from burning the hydrogen. And that's going to prove important. Now, some organizations, such as the Sierra Club, consider this too complex for you to be able to understand. And so they come up with a simple rule. I mean, organizations like to have simple rules. The most simple one, the one you will get from most organizations is the following very simple rule. Trust us in everything, and we will guide your vote. You want to know who are the good guys and the bad guys? Look at our newsletter, look on our online site. We will tell you. So that's what most organizations do. The Sierra Club goes a little bit further than that. Instead of saying just trust us, they say, you want a simple rule for what we need to do about global warming. The simple rule is no fossil fuels. By fossil fuels, they mean these three. Because these are in the ground because of fossils, not dead dinosaurs like a lot of people think, but mostly smaller animals, microscopic animals in lakes and in the ocean that died. They fell to the bottom. The carbon in their bodies didn't turn into carbon dioxide then, and so it's still there. And we use this carbon as a fuel. We use the carbon and the hydrogen. Instead, a lot of people you will find who know about burning fossil fuels don't realize that so much of the energy comes from burning the hydrogen, especially in gasoline and in natural gas. They think of them as carbon fuels. And coal is mostly carbon, and that's where most of the energy comes from. It's not pure carbon. It actually has some hydrocarbons in it. But it gets its energy mostly from just the carbon. So this is the basic physics, chemistry of the fossil fuels. The Sierra Club will tell you, oppose all fossil fuels. Now, I've talked to them privately. They do this because they need to have a simple message. And once you start getting into the subtleties and the nuances, the message gets very difficult to deliver. If they say, oppose some fossil fuels but not others, then it becomes, okay, now I got to go study a book somewhere. So it's much easier simply to say, avoid all fossil fuels. We should only use renewables. For this class, you can take it a much bigger step. And we're going to talk about the differences between these fossil fuels and why some of them actually, I'll explain near the end, why natural gas is going to play a big role. It's already reducing U.S. production of carbon dioxide. This is the United States production of carbon dioxide from 1960, well before you were born. Do we have any older people listening in here? No, just me. I was around 1960. The U.S. production of carbon dioxide rising every year, and then over the last 15 years it's been going down. The reason it's been going down is we've been getting more and more energy switching from coal to natural gas. There are other reasons too, a slowing economy, but the biggest component comes from when you switch from coal to natural gas. For the same energy, you get about 1/2 of the carbon. And so as we switch, the energy that used to be produced with coal is now being produced by natural gas, and so the amount goes down. This is part of the natural gas revolution. So here's a little thing that you will know a lot about 10 years from now. Everybody will know a lot about it now. You should know about it. We'll know a lot about it in 10 years. You should know about it now. There is a huge development going on in the United States right now that can be referred to as, most typically, let me get my chalk again. The shale gas revolution. The shale gas revolution is taking place. You're in the middle of it. Everybody in the business world who's in big business knows all about it. All of the people you elect to Congress know all about it. This is an issue that's being debated in Sacramento. It's being debated in New York. It's being debated in Washington, D.C. Russia is really concerned about this. It's comparable to the 1849 gold rush. It's not in my book, because when I wrote the book, I didn't know about it. It wasn't happening yet. This is so recent. It's like it's 1848. And the President Polk of the United States has just announced gold has been found in California. And as a result, hundreds of thousands of people will rush to California to become rich because of the gold discovery. Well, this is happening in the world today, but it's not gold, it's natural gas. And I'll tell you a little bit about that story near the end of this lecture. But you need to know what's happening and start noticing those headlines. It is really big. It's like saying, well, maybe the year is 1990, and someone says, internet? What's the internet? And that was the case back in 1990. And I remember talking to people who say, well, the internet's not going to catch on. It's too hard to use. And you know how that has changed. Well, that is happening with energy. People who are in favor of renewable energy, what is their greatest fear? Any suggestions? Anyone want to shout out? Yeah. Exactly right. The real fear is actually not coal or petroleum. They do fear, they used to fear that coal would continue on because it's so cheap. But they have a new fear now, and that is that natural gas is even cheaper. And as a result, if you want to develop solar, you have to compete with natural gas, and natural gas is a fossil fuel. And yeah, it emits half the carbon dioxide of coal. And yes, it's responsible for this going down, and that will lull us into complacency because it's going down. And they fear that solar and wind will not be able to compete with natural gas. From a financial point of view, they're probably right. So that is one of the reasons why there is opposition to natural gas, for fear that it will make it less profitable to develop solar. So you need to know that. So I started by talking about Roger Revelle. The fact that we've been burning fossil fuels means that the carbon dioxide of the world has been going up. And this is my plot of the carbon dioxide in the atmosphere as a function of time. You can look this up in Wikipedia. It was at 270 parts per million. That seems pretty small. 270 parts per million. How much is 270 parts per million? 270 parts per million is equal to, let's see, this is parts per 10, 100, 1,000, 270. That's the fraction of the atmosphere that's carbon dioxide. Really tiny. Some people, you'll read people who are not very educated in science, and they'll say, that's so tiny, how could it affect our atmosphere? How could it affect our temperature? Who cares? Look how small it is. Okay, so it's up to 400 now. It's gone up. See that recent rise? It's gone up. But it's so tiny. You have to put it in perspective. All of the food that you eat comes from atmospheric carbon dioxide. Atmospheric carbon dioxide is absorbed by plants and turned into food. They release oxygen. They keep the carbon, use the hydrogen from water, and they create sugars and starches. So this tiny little bit of carbon dioxide is the source of all of our food, even though it's so tiny. Tiny things can have a big effect. It also is the source of most of the global warming. So let me talk about how that works. This tiny little bit surrounds the Earth. Tiny bit. What it does is it provides a blanket. Now, maybe you've never thought about blankets. Do you ever wonder why? You probably didn't, because you were not thinking physics. Now that you're all physics thinkers, you can wonder questions that you couldn't wonder before. You could ask these questions. And they're good questions to ask Yury before class or in office hours. But think about a blanket. I don't mean an electric blanket. I mean an ordinary blanket. Maybe a sleeping bag. You put it on you and you get warmer. Why? It doesn't create heat. So why are you warmer? The answer is that you are creating heat, and normally that heat moves out very quickly. But if you hold it in a little bit longer, then it's moving less quickly. You're still generating it, but it's moving out slower because the blanket is an insulator. It prevents the heat from flowing. It doesn't flow as fast. And as a result, the heat builds up inside the blanket. It gets hotter and hotter and hotter until it's so hot inside that even though the blanket resists it, it leaks out at the same rate you're generating it. Let me go through that again. You generate heat at a constant rate. And normally it leaks out, and that determines your temperature. If you put a blanket on, it goes out less, it doesn't go out so fast. And that means the temperature of the air starts rising, and it rises and rises. If it were a perfect blanket, you would die from the temperature. It would get up to 150 or so, and then you'd stop producing heat. Because if the heat can't get out and you're generating it, it just raises the temperature. But with insulators, the higher the temperature on the inside, the more rapidly it flows. Finally, it gets so warm inside that the flow is equal to the rate at which you're generating it, and then we're in the steady state. It doesn't get any warmer. It stays warm, snugly warm. That's why you like blankets and sleeping bags. That's why you wear a sweater. One of the reasons you wear clothing. Stay warm, especially on a day like today, because it slows the heat. Carbon dioxide does that in the atmosphere. The atmosphere has this carbon dioxide in it. It has oxygen, nitrogen, water vapor. For the oxygen and the nitrogen, sunlight, and for carbon dioxide and water vapor, sunlight mostly passes right through, except for the part that's reflected by clouds. It goes right through, right to the ground. Then the ground heats up. It radiates its heat. That radiation is mostly infrared radiation. It comes in as visible light, and it is emitted as infrared because it's heat radiation. The radiation that you get from simply being warm is infrared radiation. It's invisible light. So this invisible light is radiated. Now, odd thing about carbon dioxide, it is completely transparent to visible light. The visible light comes right through. The infrared radiation, it absorbs it. Not all of it, but it absorbs some of it. It acts as a blanket. So you can think the heat source in a blanket is my body. The heat source for the Earth is sunlight. It comes right through the atmosphere, as if the atmosphere weren't there. It's transparent. You can see that. But if you could see in the infrared eyes, you would not be able to see very far through the atmosphere. The atmosphere absorbs this infrared radiation, not all of it, but it absorbs a lot of it, and that makes the Earth warmer. Now, that warms up the surface of the Earth. If it weren't there, if we got rid of the atmosphere, the temperature of the Earth would drop below freezing. The oceans would freeze over. We call this the greenhouse effect because people who are raising flowers and vegetables will sometimes put their crops underneath glass. The glass lets the heat come in, sunlight, but then it heats up on the inside. And normally the temperature is lost by infrared radiation and by flowing air. Hot air tends to rise. The greenhouse glass doesn't let the hot air leave. And therefore, it acts like a blanket. And because it's a blanket, it gets hotter on the inside. And so people build greenhouses. And maybe you've seen them. If you drive up through California, you'll see people growing plants in greenhouses. Sometimes they'll do something else. They'll pump a little bit of extra carbon dioxide into the greenhouse. And that makes plants grow better because that's what they use. They use carbon dioxide. Some of the people who say we shouldn't worry about global warming argue that the additional carbon dioxide building up in the atmosphere is good for plants. Are they right? Yeah, they're right. When you're evaluating global warming, you can't just dismiss every positive argument for why it might be okay. You have to make a balance. You have to ask what's the bad side of global warming and what's the good side. We'll talk about that in a moment. But you can't just dismiss one or the other. You need to know that more carbon dioxide will help plants grow. And some people argue, and they've put down the numbers, that part of the reason why there's less hunger in the world today, the so-called green revolution, it comes about because of better fertilizers, and they argue because of the increased carbon dioxide has also helped plants grow. May be true. I think it probably is true, that some of it comes from that. Been some careful scientific work on that. There are people, though, who try to get the world worried about global warming. And they will frequently exaggerate the issue in order to get people more worried. But that's not for you. You can handle the details. So that's the greenhouse effect. Now, if the carbon dioxide increases, what's happening is that the atmosphere is becoming a better blanket. By the time you double the carbon dioxide, it's almost the same as putting two blankets on. And we can calculate approximately how much the temperature should go up. And the answer is, when people talk about doubling, they normally talk about doubling it from this old level up to 540. 540 is up there somewhere. And the answer is the temperature should go up by maybe 2 degrees Celsius, about 3 degrees Fahrenheit. So is it going to double? Yeah, I think I'm pretty sure it's going to double, unless we do something about it. Why is it going to double? Well, not because of the U.S. The U.S. is actually headed down. But because this is the plot. I didn't mention this here, so let me label this plot. So this is the U.S. And these are the emissions of China. And China is now approximately twice the level of the United States in yearly emissions. It switched in, this was 2006, became the world's biggest emitter. Since then, the U.S. has gone down and China has shot up. And China continues to shoot up because it's a developing economy. Their economy is growing enormously rapidly. If you want to control carbon dioxide, this is also a key message that I make when I write articles and op-eds, when I give talks all around the world, including China, that if you are seriously concerned about global warming, which I personally am, and you want to slow or stop global warming, which I do, then consider any action you take and ask, will it work in China? And the reason is, unless it will work in China, it's not going to do anything more than slow global warming a little bit. You can calculate what would happen if the U.S. went to 0. Suppose we went to complete renewables and had no emissions whatsoever. The total sum of the world emissions would be back where they were in 3.5 years because of the growth of carbon dioxide from China and India. So if you are concerned about global warming and are not talking about the developing world, you are not really addressing the problem. In my opinion, if you're working on U.S. ways of doing this, without regard to the developing world, you're just doing what I call a feel-good measure. You are doing something which 30 years from now, when the world has enormous global warming and the consequences are obvious, you'll say, yes, but it wasn't my fault because the U.S. cut back. And I regard that as not correct. I'd say we live in a world today, you've got to think globally, you've got to act globally. If what you're doing, like building big battery-driven automobiles that are so expensive that China could never afford to use them, you are not setting an example that China could afford to follow. And therefore, you are not addressing global warming, you're addressing feel-good. I talk to a lot of environmental groups about this. And they privately, they acknowledge what I'm saying, but they say they have limited outreach and they want to do things in the U.S. But I think we have to look at China. I've had 4 trips to China in the last 2.5 years, talking over there, meeting with people, trying to help do things about this. I'm working with their major oil companies over there to try to reduce the use of coal. And I think that's what you have to do if you're really interested in doing something about global warming. You know, the whole idea that at home what you can do is start using recyclable papers and not use plastic bags is really a joke. It doesn't do anything. You guys can do this because you're studying physics and you can study the numbers. And you can look and say, what is important to do? And don't just do things because someone tells you to do it and it makes you feel good. Because the issue is, that's not the issue. The issue is if we need to stop global warming, we have to act globally. So this is the greenhouse effect. The key thing here is that sunlight comes in and warms, but it gets out slowly because the Earth, being at room temperature, emits infrared radiation, and the carbon dioxide stops that. The more carbon dioxide, the more it stops, the warmer we get. So let me now show here's another diagram of that. See up there, that's just what I was saying, that the sunlight comes in, but then the infrared radiation gets stopped, not only by carbon dioxide, but also by water vapor. This is the plot of the greenhouse gases. Next, I'm going to show you a plot that was made by my research group. It took 4 years of hard work. And it is a diagram showing how the warming. Let's see, what happened to my laser pointer? It's still here. We were able to determine the temperature. This is by looking at old thermometers whose records had been kept back till the 1700s when the thermometer was first invented. And what you see is that the temperature here, there are some cool periods. But these are all associated with volcanic eruptions, huge volcanic eruptions, and they're all short-lived. What happens is these big volcanic eruptions throw dust high in the atmosphere, and that reflects sunlight, which means we cool. But then the dust settles, and we're warm again. So we were able to show that the volcanic eruptions effects are all quite small. And they're big, but they only last for a long time. This time it was so big that the world is listed by historians as the year without a summer. It was cool all the way around the world. But notice this rise. That rise is a perfect match to carbon dioxide. Some people say, oh, that's accidental. It actually has nothing to do with carbon dioxide. It has to do with cosmic rays. Now, cosmic rays aren't changing that way, but maybe. And they come up. In science, we don't consider that valid science. When you say, I have an alternate theory, it doesn't make any predictions, but I think that's what explains everything. There are theories that people have been proposed. They have proposed that the sun is actually changing its brightness, but it doesn't match that pattern. Our data, because it goes back far enough in time, we can rule that out. Based on this plot, about a year and a half ago, I came to the personal conclusion that global warming theory was correct, that the increase in carbon dioxide is causing the warming, and if we know what happens to the future, we'll be able to predict what happens. Well, we know what's happening in the future, but what's happening in the future, if you need to predict the future, you can more or less ignore the United States. You can more or less ignore the developed world. The future is going to be determined. Let me just skip ahead here. Let me find that here. The future is going to be determined by the developing world. Here's a plot that shows what we expect to happen. This is the United States going down. These are the other Kyoto developed states, they're called. These are Europe, Australia, and so on. They're also, this is if we go down, if we agree to a treaty. But the treaty did not require China to go down, did not require India to go down, because their economies are growing. So the treaty was going to require that their emissions grow less fast than their economy. And this was a projection. This was actually published in the New York Times no, it was in the Wall Street Journal, an article I wrote about 3 years ago, showing what would happen. And what you see is the emerging economies, China, India, Malaysia, Indonesia. That's where all the carbon dioxide of the future comes from. And so if you want to stop global warming, that's really where your focus needs to be. So why are there so many skeptics? Why are there people who deny global warming? How many people in this room are skeptics, consider themselves skeptics? You don't have to raise your hand because it might be a little bit embarrassing in Berkeley. But touch your nose if you're a skeptic. Certainly a lot of you must be. I mean, 3 years ago, I was a skeptic. I still am a skeptic. Let me show you what I believe you need to be skeptical about. What happens is the global warming, I believe, is on a solid foundation now. Yes, it is happening. Is it good or not? That's harder to argue. And some skeptics say, well, of course it's happening, but it's good. Will Happer, who's an eminent physicist, says it helps plants grow. It helps relieve hunger. It's going to be good. Other people say, well, what about Hurricane Katrina? What about Hurricane Sandy? We don't want more of those. You know, and I agree, we don't. Were Hurricane Katrina and Hurricane Sandy caused by global warming? Let me give you the scientific answer. There's no plausible reason to think they were caused by global warming. And yet that's what you'll hear from the skeptics. And the problem is the skeptics are right. Hurricane Katrina and Hurricane Sandy are not related to global warming. They just happen to do a lot of damage. People will make arguments that the sea level was higher and therefore it did more damage. Well, the sea level was higher. It's about 4 inches higher than it was 50 years ago. 4 inches higher. The sea level from Sandy was up 8 feet. So they say, well, yeah, but 8 feet, 4 inches is more than 8 feet. But that's so misleading. The damage, if it were 4 inches less, would have been just as bad. So what's going on here? And again, I say you cannot find a scientific paper that makes a plausible connection between Hurricane Sandy, Hurricane Katrina, and global warming. They just don't exist. Let me show you some of the data on global warming. This is a list of the number of hurricanes. So versus time. This is not in the textbook, but it just shows that it's widely known the number of hurricanes has been going up. See, at 2004, I think when it ends, it was higher, much higher than it was in 1950. In science, we refer to this as data that has an inherent bias. And the reason is we're much better at finding hurricanes now than we used to be. Let me show you a plot from 1933. The only thing you need to know from this plot, did I misplace my laser pointer? Here it is. The only thing you need to know from this plot is the simple fact that we are much better at finding hurricanes now than we used to. Go back to 1933, and you find, here's a plot of all the hurricanes. A lot of them hitting the coast, none of them far out at sea. None. Why? Not because there were no hurricanes there. There are no hurricanes plotted. The reason is we didn't know about them. We didn't know about them for 3 reasons. We didn't have satellites that photographed hurricanes from space. We didn't have automated buoys that float in the water and record winds automatically. And third, ships stayed away from that area during hurricane season because they were so far from the coast that they could be damaged and no one could come and rescue them. So there's what we call an observational bias. And whenever you're doing anything scientifically, you have to be aware of observational bias. Now we have lots of hurricanes out there, but we don't think, nobody thinks it's changed. That entire difference between 2005 and then is because then we didn't measure them and now we do. In 2005, for the first time, we ran out of letters. There were more than 26 named tropical storms. Did we run out of them because the number of storms has been increasing? No, we ran out of them because now we detect more storms. Can we determine whether the number of storms is increasing? Well, what we can do is go to an area like the coast where every hurricane that hits is recorded in a newspaper. And let's just compare the hurricanes that hit the United States at different times. So I made a plot of that. This is something you can do online. You can go to the Hurricane Center and get a list of all the hurricanes. And what you find is these are the total number of hurricanes in black. I look a little bit lower on this side than this side. That's actually true. The number of hurricanes hitting the U.S. has actually decreased over the last 160 years. This is, we call it, you don't have to know this term, but in science we call it an unbiased subsample. You pick an area, a subsample, in which is unbiased, because these storms are always reported in the newspapers. And when you do that, you find the number of hurricanes is not increasing. Does that contradict global warming theory? It turns out it doesn't. Global warming theory does not predict storms will increase. Well, some theories do. There are many theories of global warming, and here's what you have to watch out for in the newspapers. There are theories that say that storms and hurricanes will increase. There are other theories that say they will decrease. There are other theories that say they'll stay the same. Nobody knows which theories are right. If someone reports the storms are going up, as you saw in this first plot, the newspapers will report storms are going up, as is predicted by some global warming theories. And that's not a lie. But it's easily misinterpreted by anybody who didn't take physics for future presidents. You've got to have your ears sharp and listen for those qualifications, because you have to explain this to your friends, neighbors, and parents, and someday children. Although they'll take this course too, I'm sure. I'm not sure, but hope. And you'll explain to them about observational bias. And, oh, storms are actually going down? Well, it turns out that is predicted by some global warming theories. Well, then how can you prove global warming true or not? Well, the way you prove global warming true or not is not by looking at hurricanes, because nobody really knows what's going to happen with them. You do it by looking at curves like this. The theory predicts it should match carbon dioxide, and it does. Global warming is real. I'd like to summarize my feeling about this in the following overly simplified way, which I think you will get to see the wall behind. Here's my summary statement. This is a personal statement, and may not be the opinion of Yury or other people, but it summarizes what conclusions I have reached as a scientist. When people refer to climate change, it's typically something like Hurricane Katrina. You'll hear statements made very carefully, such as, you don't want more Hurricane Sandys, do you? Well, then you must support the global warming legislation. You'll notice they're not saying that Hurricane Sandy was due to global warming. Now, it may get worse, and that's part of the problems. As we increase the temperature, we're entering a temperature regime that hasn't existed for 2 million years. And therefore, we don't know what the changes are going to be. And in general, once we have a finely tuned civilization, big changes are usually bad. They can be good, as Will Happer will argue, carbon dioxide, more plants. But generally speaking, they're bad. Sea level is rising. I believe that's due to global warming. The Arctic is melting. I'm not sure if that's due to global warming, because the predictions in Antarctica were backwards. More extreme events. We're going to have more hot days. That's true. It's a consequence of warming. We're also going to have fewer cold days. Cold spells actually kill more people than hot spells. So the number of deaths due to weather variability is likely to go down. You don't hear that, because mostly people are trying to get you on the bandwagon to stop global warming. I would like to get you on the bandwagon to stop global warming, but my approach is you should learn the physics so you know which arguments are valid and which ones aren't. I have deep opposition to former Vice President Al Gore because he is training people to go out and argue that we need to stop global warming. But he's not giving them a balanced argument. He's teaching them all the things that might be bad. His movie, An Inconvenient Truth, when it came out, I went through it minute by minute, and I found that 85% of it was either highly misleading or wrong. And I've written this up. You'll find it's in my textbook, so you've seen that. Most of what he says is wrong. I believe he's doing it because because he's concerned about global warming, as am I. And his way of convincing people that global warming needs action is to exaggerate. But I find that exaggeration is not a good way to persuade anybody because it works for a while. I've given talks at lots of groups, and one of the things I'll show is that the polar bears are not dying because of global warming. Science shows no polar bears have died from global warming. From the receding ice in the Arctic, no polar bear deaths so far. Al Gore believes they will happen in the near future. But in his movie, he leads you to believe that this is happening. And I've had people come up to me at these meetings when I spoke on this and said, "Are you sure no polar bears have died?" And I say, "Oh, yes, this is the National Academy of Sciences has verified this. It's been studied scientifically. They may die in the future, but not yet." And this one woman came up to me and said, "But that's why I became an activist, to save the polar bears." I said, "Well, you should still be an activist to save the polar bears. It's just that they haven't died yet." But she was really upset that she had been lied to. So exaggeration is not, in my mind, something that scientists or scientifically knowledgeable people should engage in. So what can we do about it? Let's see. Oh, by the way, has global warming stopped? You'll find a lot of people saying, "Oh, we have to explain the fact that it stopped." This is the global warming. And this is the claim that it stopped. But hey, it stopped back here, stopped back here, stopped back here, and look at that. If you're going up a flight of stairs, every time you get to a platform, you might say, "Ooh, I have no more steps to climb. I've reached the top." Well, this is a jagged rise, mostly due to variability in the sea. And to claim it stopped, I wrote an article back 10 years ago saying, it might not warm for the next 10 years, and if it doesn't, people will mistakenly think it stopped. But it's just because you're going up a jagged rise. And not every leveling is an indication that it stopped. I believe, based on the curves we've seen and based on the match between carbon dioxide, the smooth match, not the jagged peaks. So I don't believe global warming has stopped. And I've argued that statistically, and not everybody's convinced. But I don't see evidence. I don't see compelling evidence that global warming has stopped. Okay. So what can we do? As I look around the world, and I'm now the scientific director of a nonprofit organization devoted to studying and stopping global warming. And as we looked at everything that might be done, we see there are two things that are much larger than anything else. One of them is energy conservation. And the reason for this is that we waste most of the energy we produce. Take the electric blanket example. You can have an electric blanket and it'll keep you warm, and the electric blanket can be thin, but you can have a nice, fluffy, even more comfortable comforter filled with down, and you don't even have to kill the birds to get the down. It'll keep you just as warm. But other things, I grew up in an era when energy was so cheap that you would take a classroom that seats 500 people. You're not going to believe this. You won't believe that someone actually did this. Imagine making a classroom that sits 500 people, and it doesn't have any windows. So in the daytime, you need artificial lights. Can you believe that? Some people are looking around and realizing that's the classroom they're in. Why could we build a room like this with no windows? And the answer is electricity was so cheap. This is more convenient. You get the same lighting all the time. You don't have to vary the lights night and day. So let's build a big room with no windows. And why not? Electricity is for free, almost. So here we are. What this illustrates is how much energy we could save. Here's a physics issue. Okay, now this is something you really study in Physics 7. But if an object is here and has to go here, the question is how much energy does it take? And the answer is, in principle, 0 energy. All of the energy it takes is overcoming friction. You're not lifting it. It starts at rest and it ends at rest. In principle, you could go from here to here and use no energy. If it was ice and there was no air resistance, you could start skating and you'd slide and you'd get there. So our cars are 100% wasteful of energy. How much better can we do? When I was a kid, my first car, I was really proud because everybody's cars got 15 miles to the gallon. I got one that had 29. I got a Volkswagen Bug. 29, twice as good as anybody else. These days, 29 is not considered very good. My Prius actually, honestly, does get 50 miles per gallon. We can do so much better. So as our nonprofit looked at this issue and studied around the world, what we decided was there are many, many groups working in China to improve efficiency. When you improve efficiency, you save money. And therefore, in China, in India, in the developing world, you will see more compact fluorescent light bulbs than you see in the US by far. And the reason is they care about the cost of electricity. So they're going to be much more efficient than we are. We can improve our efficiency too. That's a good thing to do. But the important thing is to get the developing world to do it, and they're already doing it. And there are lots of groups in the US that are helping them do that. So we decided there wasn't much that our small nonprofit could do. But there is one thing that's equally big, or almost as big, not quite as big, but almost as big. The next biggest thing we can do is to switch the developing world away from coal. What can they use? Can they use solar? Can they use hydro? China's using hydro, but in the process, they are destroying, according to when I was in China, they talk about the Three Gorges Dam. And they say there were 1.2 million people who were displaced, but they all volunteered. All of them, everyone in China, volunteered to leave his city. Okay, there were over 100 cities destroyed. There were 1,000 villages destroyed. And they all did it voluntarily for the good of their country. Only in China only under communism can you get such unanimity. I don't consider hydro to be a viable alternative, and I think it does enormous damage to the environment. What is the alternative? 70% of the energy used in China comes from coal. And not only that, but it leads to horrendous air pollution. The World Health Organization just last week came out with a new study. The number of people dying in China every year from air pollution, due mostly to coal, is over 2 million people per year. 2 million per year. What is it in the United States? Write down a number. Make a guess of how many people in the US die from air pollution. Just write it down. You don't have to tell me. Just take a guess. Now, the EPA, the Environmental Protection Agency, has actually come up with a number for this, which they have published, and most people don't know about it. The number is 75,000. That's in their publications. Almost nobody knows about this, I think because the coal mining states don't want it to be widely known. That's my cynical reason. We like to think we have great air in the US. Well, we actually have really great air here in Berkeley. Well, every time I come back from Beijing to Berkeley, I just enjoy breathing. I wonder if I have that picture here. Oops. Oh yeah, here we go. Can we turn on the lights for a moment? Photograph I took. Turn all the lights off, please. All of them. You see that picture? It's a picture I took from my hotel in Beijing at sunrise. Call it Beijing sunrise. Okay, lights back, please. It's a map of China showing the air pollution. It's spread all over the country. This is another map. Green means healthy air. And you can see yellow is moderately polluted. Red is unhealthy. Brown or orange is very unhealthy. Purple is critical. China is in terrible shape. And the number of 2 million people per year dying is a completely plausible number. I call this, in my mind, the most urgent and terrible environmental disaster in the world today is air pollution, not only in China but also in India. It kills more people than AIDS, more people than tuberculosis, more people than polio, more people than hepatitis. And yet, my guess is that right today, right now, is the first time that this is being presented to you as a big environmental problem. Why is this not the central focus of environmental groups? Oh, let China take care of it. It's their problem. You're not thinking globally if you say that. So how can China take care of it? Energy conservation is one. The next one is shale gas. Shale gas. Okay, so I'm going to show this little movie. Have the lights dimmed, please. What is shale gas? Shale gas is the revolution that's taking place today. Also in the front. You don't have to show me. I'm still in the front. Yeah. Okay, I'll just talk. Shale gas is the energy revolution that's taking place today. And let me turn these off. And there's enormous opposition to it. Let me show you how shale gas works. There's a layer of shale deep underground that contains enormous amounts of natural gas. A few years ago, people thought it could not be recovered. Now we have a way of doing it. You build a concrete platform, and then you start drilling down. Oops. That didn't work. Let me go back. Okay, so you start drilling down. There's the water layer where you get drinkable water. You drill past that. Then you pull your drill back out. You put down what's called a casing. Through the casing, you pour concrete. The concrete goes out the bottom and comes up the sides. And now what you've done is made a concrete shield to protect the water. Now what you do is you drill again. You drill down deeper and deeper. You go down sometimes half or even a mile deep, way, way below the groundwater, into the shale layer. When you get to the shale layer, you turn the drill and drill horizontally. And there you are drilling horizontally. Then you pull the drill out, pull out drill, and you put in a casing, Now you pour in the concrete, push it down, it flows around the outside and protects the outside of the pipe. Now you take away the big stack that's on the outside, and you replace it with a little structure that's called in the business a Christmas tree, and you bring in a lot of trucks. First thing you do is you go down, you send down an explosive. So there's the explosive. You set it off, boom, boom, explode, please. There. Okay, that makes little holes or tiny little fractures. Now what you do is you pull that out and you pump down water under high pressure. The water takes those little cracks, so bring in the water pumps. The water under high pressure fractures that. So the fractures spread, getting into the rock that has the gas in it. This is inside a fracture. It's an artist's depiction of what it would look like. 2 millimeter holes with little particles of sand that hold it up. And this is where the gas is. So the gas is coming out of the rock. But before you take that gas out, you send down a plug, and now you send down the explosive again. Set it off, boom. Now you send down the water, and you fracture that. Then another plug, another explosive, and you have these many stages. Now once that's all done, you remove the plugs, in this case drill through it, and now the water comes flowing back out, That's called the return water. You want to be careful not to use that to pollute anything. And then the gas comes out. And this is called fracking. And that's what's left on the site. I've been to these sites. It's half the height of this room. Okay, the lights back on, please. Enormous environmental opposition to that. Oh, let me show you the greatest. Actually, lights back down, please. I want to show you another movie that illustrates the opposition. Okay, you can turn, yeah, you can turn that light off. Okay, so here we go. Now, this is a movie that has almost got an Academy Award. It's a very, very popular movie, and it has motivated a large number of people to oppose fracking. So let me show you this movie. And let's see, I don't have the sound set up, so what I'm going to do is put this speaker close to the computer so you can hear it. Do you know what natural gas is doing to your water? Okay, lights on for a moment. How many people have just seen that flaming faucet for the first time just now? Raise your hand. Okay. It's very well known, very popular. You can get that on the internet. Go on YouTube, put in flaming faucet, you'll get that. It comes from a movie, Gasland, which has inspired the huge environmental movement against natural gas. You notice what the sign said at the end. Do you know what natural gas is doing to your tap water? It does not lie. The fact is that flaming faucet did not come from natural gas. It came from gas in the soil, which comes about from bacteria in the soil. This is well known and understood even by the maker of the film. It did not come from natural gas drilling. The movie says, do you know what natural gas is doing to your faucet? There's an implication there that any thoughtful person would assume that that flaming faucet came from the natural gas. Let me show another movie. This has subtitles, but we'll still try to get this out. Okay, lights down again. This is Josh Fox. He was the producer and star of the Gasland movie. Here he is giving a public lecture when someone in the audience stands up and asks him a question. The question is, but didn't flaming faucets start long before fracking took place? And here's what he says. Okay, lights back on. Right now, I think what most people know about fracking is not true. I've been studying it in some detail. I could now give you an hour and a half lecture on it. The water, you don't have to use fresh water. You could use a deeply buried water that's available at all of these sites. You don't have to use fresh water. The water that comes out, no, don't dump it into the environment. Yes, that was done in some sites in Pennsylvania by irresponsible groups, and they should be put out of business for doing things like that. You can certainly regulate it, so anybody who does that in the future gets bankrupted. In terms of gas leakage, that's a problem, but that's much more easily solved than any other technological business in this whole field. So keeping the following in mind, that personally I support fracking as the biggest thing we can do outside of energy conservation to get China off coal. The most important thing they can do, and that's why I'm traveling over there to China, in order to stop global warming. You can buy your own Tesla Roadster if you can afford it, and that will have no impact whatsoever on the future of global warming, because the big countries of the world, the countries that are going to produce most of the carbon dioxide, can't afford Tesla Roadsters. But if we can get them from coal to natural gas, we can cut their emissions in half. And that means global warming, instead of hitting a critical time in 30 to 50 years, will take twice as long, 60 to 100 years or more. And in that time, technologies such as solar and wind can really get a lot cheaper. So that's my road path to stopping global warming. And I will end there, and I'll hang around for anybody who has questions they'd like to ask. So thank you very much.